Hello everyone. I will show you how to complete the assignment 4, which is building the machine learning model for the multi-class text classification. Okay, I have already started my virtual machine, and then now I open the browser. Okay, then as usual we go to the Azure portal website. Okay, we use this credential. And the password. As usual, we're going to create the machine learning workspace. So this part you have done many times. I don't have to explain again. Okay, so provide the information. For the resource group, I'm going to create the MLA Assignment4 RG. Okay, for the workspace, MLW Assignment4. Okay, for the region and everything, I just use the default. Click review, create. Yeah, wait for a while. Then click create. Okay, this will take a while. Just wait for a while. Okay, in the meantime, I will open the screenshot template to see what we need to do with this. Okay, create machine learning, after that compute instance, create pipeline, after that successful execution of the pipeline and evaluation result. Yep, so that's the training the pipeline. So only 1, 2, 3, 4 screenshot. Okay, that's the assignment 4. Okay, so let's come back here. After that I have not create a sample. I just duplicate, make a copy, and rename this sample. Okay, yeah, almost done. Just wait for a while. Okay, done already. We can go to the resource and then open the machine learning Studio. The next step is to create the compute instance. Okay, so new. After that, provide the name for the compute instance. Ryan, COMI. Okay, choose the cheapest. Click review and next first. Yeah. Then just choose the default setting. Then create. Okay, let it run for a while, and we can go back to the machine learning workspace. The yeah, here you go. This one. Yeah, so I can create a screenshot. The first one. Okay, so replace the first screenshot with this. Okay, after that, go to the designer. We're going to create a new pipeline. Okay, for the pipeline name, you're going to rename this with the train text classifier. Okay. Save it. Okay, then we're going to use the Wikipedia SP500, the news website. Yeah, so Wikipedia SP500 dataset. We have two version, yeah. So yeah, I think let's see pre-process. Yeah, I think we can use this one, the first one, version 3. Okay, let's have a look on the preview the data. Okay, 466 3 column. Let's compare with this. Any different? Same, actually the same. Yeah. Yeah, the same, so doesn't matter. Okay, after that we going to choose the pre-processed text. Okay, in the pre-processed text we double click to change the setting. Basically we just choose the default setting. Yeah, language English, expand verb contractions through, remove stop word through. Yeah, everything is based on the default. We only want to change the column to clean, this one. Yeah, edit the column, the column name is text. This one. Okay, then close, save it. So if you see this, okay, preview the data. Okay, I quickly show you that this contains 466 row and 3 column. This is the title, this is category, this is the text. So we're going to train the model to classify the text based on the content of this column, and then categorize whether this news is about information technology or other. And let's see this column. We have 10 categories here, like financial, consumer, customer, consumer discretionary, IT, industrials, healthcare, energy, and so on. There are 10. Yeah, we're going to classify. So there's a name is a multi-class classification, because we have 10 classification. Previously we only have a 2 classification or binary classification. So we have 10 now. Yeah. Okay, close. Then after that we're going to directly, because everything has already been processed here with a single process, then we're going to split the data. Okay, split the data, and we're going to do a 2 representation of the data, so 50-50, 50%, 50%. Okay, 50-50. Okay, after that split the row 05 true, 0 true, stratified. Yes, yeah, you want to stratify based on the category. So the purpose is to make equal. Yeah. So the splitting 50-50 based on the almost equal percentage of the category, not just random, but stratified based on this category column. Okay, after that we're going to do the features engineering. So we're going to use the 2 method, yeah, using the hashing, yeah, and then also the n-gram. Okay, so for that purposes we need to split this into 2 parts. Yeah, so I just make it a little bit smaller. Okay, so look for the n-gram features. N-gram. Okay, extract n-gram features from the text. Okay, 1 and then 2 for the training and for the testing. Okay, like this. Yeah. Then after that in the n-gram you're going to configure to pass the this data set from the right here to go into this data set. Okay, sorry, this one is to compare. We delete first. Yeah. Okay, so we connect the first data set to the this one. Okay, after that the content of this is passed to the select column. In dataset. Okay, here you go. Yeah, pass here. Okay, and then in the n-gram itself, we're going to configure the column to be processed is the pre-processed text. Be careful, guys, because this is case sensitive and must be exactly the same. Yeah, pre-processed text. And then you're going to create the vocabulary. The n-gram size is 2, and then using the weighting, the term frequency and inverse document frequency 325, and then 5 minimum n-gram, and then normalize true. Okay, yep, then save it. Okay, close. Then connect to the dataset. In the select column in the dataset, yep, drag and drop, connect. Yeah. Okay, good. So still error because waiting for the other one to connect this one. Okay, in the select column dataset, you're going to configure to include all columns, but you're going to exclude the title text and preprocessed text. So include the all column, and then after that we'll exclude by the name, the title, and then text, pre-processed text. Okay, so we only going to keep the n-gram because this 3 will be excluded. Okay, save it, then close. Yep, so this is the select column. Yeah, then on the second extract n-gram, we're going to configure the testing dataset, the second half of this data going to left side dataset here, and then the output of this text that already been removed, only left one column. Yeah, this going to pass into the vocabulary. Okay, yeah, so this is the more or less the diagram is like this. Okay, this one coming to the, no, this one is wrong. Extract n-gram go here, after that this one is go there. Okay, this one is wrong. Okay, yep, on the right side go here. Okay, correct. Yeah, this one's correct. Okay, after that we're going to drag the feature hashing on the left side because we're going to compare two algorithm. So look for the feature hashing. Okay, so in the feature hashing we're going to drag the data from the left after split to this. Okay, after that we copy another one, feature hashing, we get the connection from the right side here. Okay, and we configure the column in the feature hashing. So the column name is only pre-processed text. Okay, save it. The hashing is 10, so we will prepare the 2 power 10 or the 1024 columns for the unique word. N-grams is 2. The rest is okay. So we configure the same thing with this one. Okay, the column is a pre-processed text. Okay, save it, close, and let's check the extract engram, the second one. Yeah, so you have to configure with the same setting. Which one is this one is a pre-processed text, and then this one, the second, is read only. Yeah? After that, 2 gram df idf, and then 325, and then minimum engram is 5, maximum is 25. Minimum word length is 3, maximum word length is 25, minimum engram is 5, and then maximum 1, and this is true. Okay, yeah, so save it and close. Yeah, so the first feature hashing we already configure. Then we complete the line. After this, you're going to create the select column in the dataset. Okay, after that, drag this data from the picture hashing to the dataset. Sorry. From the correct. From the picture hashing, go to the select column. Yeah. After that, you configure the select column, include all column, and then exclude the like just now. Yeah. So include all the column, and then the exclude column names. Yeah. The title, text, and pre-process text. Okay, save it, save and close. Okay, after that we're going to configure the second hashing, or before that we just configure the train the model first. So we add the multi-class logic segregation. Yeah, this one, to train the model. And we need to create the connection. Maybe we do it on the right side first. Okay, train the model. Okay, so from the multi-class logic segregation, we drag the line to the untrained model. After that, the select column in the dataset, the output is assigned to the right set here. Okay, then double click the train the model. The column is a category which we want to find out. Okay, and train the model column name category After that, output setting, everything is nothing, no, just default. And then for the second instance, we also add another train model. Okay, then connect the train the model to the second algorithm. Wait, so train the model from the select column. Okay, this one is wrong. Should be from here. Okay, wait, let me make more clearer. After the select column, then it's go to the the right hand side, the dataset, yeah, untrained model and dataset. So this one is wrong. Okay, so the model is here, the dataset is here. Yep, so that's better. For the right hand side, after the extract, you go to the select column, then you pass this here, untrained model. Okay, sorry, this one. We have not add the algorithm is yeah, multi-class, still the same. Multi-class, okay, so I need to put in the middle like this. Okay, so put like in the middle. Yep. So the training data, the algorithm go to this train model. After that, after select column, come to here, the list of the word. Okay. So that's what happened. Okay. Now we're going to see more about the scorer model. So after the train, then we drag the scorer model. Okay, scorer model. Okay, in the scorer model, then the output of the second n-gram. will be sent to the this one. Okay, and then in the train model, the label column is the category. Typo. Okay, save already. Yep. So let's have a quick checking again about the layout and the connector. From the extract engram on the left, go to the select column, and then on the right, the result vocabulary, go to the engram on the right side. Okay, yep, so more or less like this. The final part is to compare. Yep, so almost similar. We drag the score model here, and then in the train model we go to the this one, train model, and the dataset we get from the second hashing. Okay, looks like everything okay now, in correct place. Yep, so going to put the last one, the evaluate model. Okay, so a bit long, but quite tedious, so have to be extra careful. You save, after that close. Okay, after that let's try to submit, and later if there is any error, then we can configure. In the meantime, we check the compute instance. Yeah, it's already created, and currently is online. Okay. Yep. So now we can submit the job in the pipeline, in the designer. Save, after that configure, submit, create a new. Okay, so MLA assignment 4. Okay, so create new, then next choose the compute instance, next submit. Okay, so let me check if there is any error. Okay, submitting, then you can close this notification. You go to the jobs, After that, here you go. Yep. Okay, just wait for a while for this to complete. It will take maybe 5 to 10 minutes. So far looks okay, and then the data already been split. Yeah, while waiting, maybe you want to see what happened after the data is pre-processed. So previously was 466 row, yeah, and this one is the news, yeah. Then after that we open the after the pre-process. Okay, so result data set, yeah, you can open. So the number is removed, and a few others. You can see how the pre-process changed the text into the okay, like this one, yeah, off, yeah, Manhattan Avenue of the American, yeah. So you can see Manhattan Avenue off is removed, D also removed, yeah. Okay, that's a noise word. And then exploitation, yeah. So BR is normally a break, yeah. The HTML, those indicate the new line, yeah. Okay, so this is an example of after pre-processing some content change. Okay, yeah, I got the error here. Select column in dataset. I think typo, yeah. Let's see here what happened. Okay, pre-process, pro-process, yeah. Okay, so typo. I go back to the designer in the select column dataset on the right side. Designer. After that, okay, so make some changes here in the select column dataset. Yep. So edit. This one is wrong. Yeah, pre-process tag. Okay, maybe I exclude. Title, text, and then pre-process. Correct, right? So that's what we need to in the select column. Title, text, pre-process tag. Okay, save it. Yeah, then run again. Save first. Okay, so choose the compute instance. Okay, yeah, so let me configure submit. Then after that, yeah, select existing. Okay, you can go back to the jobs. Go to the latest one. Yep. So here you go. Continue from here. You notice that those who have already completed, it won't be redo. Yeah, it will continue from the stage that error. Okay. So in progress, training the model. Okay, now it's scoring the model. Yeah, while waiting, we can check. So after the split data, okay, first from the 466, I think there are many empty or missing value. Yeah, that caused the data not only left a few row only. Yeah, only left 84. Yeah, only left 84 from the 466. Many are removed. Yeah. Then here in the n-gram extractions, preview the data, result dataset. Okay, because we split to 50%, only left with this. Yeah, this one is the column that pre-process. So you scroll down, then after that scroll to the right. Yeah, so we have those the word that n-gram. Yeah, 2 grams. This one. Yeah. Affair, affect, age, aim, allegedly, America, prawn, yeah, American company. Yeah. That's the text generated by the tokenizer, token by token, 2 gram. Yeah. After that, we look at this is the same. Yeah. Then select column, only select one column because the other 3 you exclude. Wait. Yeah, a bit slow because many columns, a bit big. Yeah, just wait. Okay, expand this one. Yeah, this is the text. Yeah, and only left the pre-processed text. So the title and then the original text and category are removed. Okay, then after that train the model, score the model, and evaluate the model. So we compare which one is better with the higher accuracy. Okay, so here in the evaluate the model, preview the data evaluation result. Okay, so overall accuracy, so 0.3 and 0.4, so higher accuracy in general. The n gram, the 2 grams in this case. Okay, everyone here, you have the accuracy and then the micro precisions and macro precision. What the difference? So you know that we have the 10 classification. So the micro MI, the micro precisions is meaning that you would like to calculate the precisions, consider all the classes. So the 10 classes together, and then sum after that the average. But the macro precisions, you will find the average of each class and then sum up together and then average. So that's the difference. So you remember that we have the 10 classifications in the original data here. Okay, here you go. In the category, we have the 10. So micro MI, calculating precision considering all classes. So all the classes add up together, and then after that find the average. But the macro MA is you find the precision for the each class first, and then after that add up together divided by 10. So that's the micro and macro precisions, the difference. Okay, so when to use the micro MI, micro, use when you want to evaluate the overall performance of your model across all classes, especially when there is significant class imbalance. Because this one is an imbalance. So some is high, some is low. So it's better to use the micro MI. But the macro precision used when you want to ensure your model performs well on each individual class, even if some classes are much smaller than others. Okay. So that's the explanation about the difference between the micro and macro. Okay. So here you go again. Preview the data. So in that case, here for this training model, the on the right 2 gram is performed better. Perform better, this one. You see the value is better. And how the confusion matrix. So let's see the comparison. For example, the score the model. So we can right click after that preview the data. Okay. Not this one. I think one more. Under wait. So train the model. View the log. Okay. Then after that go to the images. This one is the the complete more complete images. Okay, this one is the left. Left is the left part is the hashing. You see, this is a conversion matrix. Okay, so when highly predicted, so this one healthcare, and so this one is predicted, and then this is actual, how many percent. So like, so for example, this one predicted as a consumer, and then the actual is the healthcare is 4.3%. Okay, so you look at the this one, consumer and consumer. So too small, maybe 56%, and then the this one. After that, actually the good is like this, in this one. So when this high, meaning the true positive is good, because correctly predicted. Okay, financial is also financial, predicted as financial, and then after that the actual is also financial. So the 1 2 3 4, and then 1 2 3 4, okay, 25%. Financial is good, and then consumer also good, 56%. Healthcare also 70%. Okay, but a few others like materials, telecommunication, utility, which small, the result, the true positive is very low. Okay, so that's how to interpret the multi-class confusion matrix. Okay, so look at the second. It is, so this one is the diagonal, the true positive. Okay, so we have seen how to complete the assignment 4, and for the screenshot you need to produce the screenshot for the okay, here, created pipeline in Azure ML Designer, and then this one is execution. Okay, so let's go to the designer. Here you go, and then we want to minimize a little bit. Okay, still too big. Okay, maybe we can adjust a little bit. To make it okay, better now. Okay, so too small, never mind, as long as can screenshot. Okay, then after that in the pipeline, sorry, in the submitted job, okay, confirm. So let's zoom. Okay, Okay, 60%. Yeah. Okay. Okay, everyone. This is a bit tedious and a bit long, yeah, but we managed to collect the correct screenshot. Okay, so I save it. Okay, so we have completed. This is the output of the assignment 4. Okay, yep, maybe after this we can take a short break. If you have any questions, you can let me know. Thank you.